Okay, learning target today. I can multiply polynomials. Today is going to be just kind of a review day of some just general procedures for how to multiply polynomials. As we get into our unit is going to deal with rational expressions and rational equations. So we're going to have to deal with multiplying some different groups of polynomials together. It helps if we can remember some of the shortcuts here, as well as just the good process to use when simplifying those. So we've got a few different special cases here of how to go about these multiplications. First off, classic distribution problem. If you've got a number outside a multinomial in parentheses, take that number and distribute it, multiply it by each of the values inside that parentheses. When you're multiplying a difference of two squares, you're multiplying two numbers, okay, where the components of these two numbers are the same. I've got x and x, y and y, but the sign is different. I'm adding in one and subtracting in the other. That the result of this product is a difference of two squares. That I'm going to have x squared minus y squared. This happens because even though this is a FOIL problem, we're going to multiply x times both terms in the second number and y times both terms in the second number. When I do that, my two middle terms are going to be the outside and inside are going to be x times negative y, which would be negative xy, and y times x, which is going to get us positive xy. And those are always going to be opposites, and so they're going to cancel each other out. And so when you see a product like that, you can know that it's always just going to be x squared minus y squared. You don't have to go through and show the intermediate steps. Some of you may want to, and I'm not going to punish you for that if you do, okay? Because I think that can't, especially for some of you, is good practice to keep yourself in mind of what you're doing. Perfect square trinomials, where I'm taking some binomial and I'm squaring it, either adding them or subtracting those numbers, and I square that sum or difference. What I'm going to be turning into is I'm going to have this perfect square trinomial, where I'm going to have the x term squared and the y term squared, and then I'm going to have 2 times x times y. Because if I think about this, this is really a FOIL problem where I'm doing x plus y times x plus y. Okay, because that's what x plus y squared means. And so I'm FOILing this out. I get x times x is x squared. Y times y gets me the y squared. And then my outside and inside multiplications, the x times y gets me xy. The x times y gets me xy. And I combine those, I get the 2xy. If the sign in between them is negative, then the sign on the 2 is negative. Okay. That's another little shortcut if you know. Otherwise, multiply it out. But should not be x plus y squared or x minus y squared, because x minus y squared is this product. Okay, x plus y squared is not, x squared plus y squared is not either of these. Okay. Then in general, when you're going to have two binomials, FOIL them out, that it's going to be, are always going to have that first term squared and the last term times each other, and then x times b and x times a, so a plus x, or because the coefficient then would be a plus bx. Honestly, when you see a problem like this, just FOIL it out. Do those 4 products. First, outside, inside, last. The same goes with this general quadratic trinomial. When you've got coefficients or maybe even different variables in any of these terms, just multiply that FOIL process out. First, outside, inside, last. I don't really put a lot of stress on knowing these formulas. Just go through the process and multiply them out. So let's look at a few examples. Again, we've looked at problems like a lot of these already this year, so none of this should be really new. And you've seen it all in the past as well. So I've got 3x times 5 minus y. I want to take that 3x and distribute it onto the 5 and the negative y. So I'm going to take 3x times 5 and get 15x, and I'm going to take 3x times negative y and get negative 3xy. Remember, when you're multiplying terms that are going to have multiple variables, convention would be to write those in descending order alphabetically. So x comes before y, so I write x and then y. And mostly we just do that to simplify things when we want to combine terms so that we can more easily see which terms are like. And so we just write them in descending alphabetical order, just as a clarity's sake. Here we've got 2x minus 6p times 2x minus 6p. Well, look at this. I've got 2x and 2x are in the first place. 6p and 6p are in the second place, and I've just got a difference in signs there. That means this is one of these difference of two square problems. So in order to do that product, I can multiply the first terms. So 2x times 2x gets me 4x squared. And then I can do 6p times 6p is 36p squared. And it's a negative 6p times a positive 6p. A negative times a positive is negative. So my product is going to be 4x squared minus 36p squared. And because it's in that form, I don't really need to show that intermediate step. But I know that if I did FOIL this out, my middle terms would be 12xp and negative 12xp. Well, those are going to cancel out. They're like terms with opposite coefficients. So those add up to 0. And so this is going to be my final product. All right, here we go. We got a fraction in there. We've got coefficients on two different variables, and we're squaring this sum. So when we see that square, remember that that means that it's not just square this number, square this number. That means we're multiplying this number by itself. That means that this is a FOIL problem, and I should do my 4 products. Especially when you've got this fraction in here, I think it just makes sense to just do it that way instead of trying to look at the pattern. So let's do that. Let's take our 2/3 x times 2/3 x, first terms. So 2/3 times 2/3, multiply numerators, multiply denominators, that's 4 over 9x squared. Outside terms, I got 2/3 x times 4b. 4 is 4 over 1, so 4 is in the numerator. So I'm only going to multiply the numerator by 4. So I'm going to do 2 times 4, that's 8/3 bx. Remember, variables, put those in alphabetical order. So b comes before a. Inside, I've got 4b times 2/3 x. And that's the same product that I just did. So that's going to be 8/3 bx. And then finally, last terms, I've got 4b times 4b. That's plus 16b squared. Multiply the coefficients and the variables. When you multiply, you add the exponents. Finally, we've got like terms here in the middle that are bx and bx. When we have like terms, we add them, but add the coefficients. Don't change the power on the variables. And then when we're adding these coefficients, okay, we're adding fractions. They have like denominators, so all we need to do is add the numerators. So our final product here is 4/9 x squared plus 16/3 bx. We added the 8's. The 3 stayed the same. The bx's stayed the same. Plus 16b squared. Okay. But think through that process of I've got to do the double distribution. I've got to distribute the 2/3 x on both terms in the second, and I have to distribute the 4b to both terms in the second. Last example we'll look at here is D. And this one's got a little more operations going on here. We've got x minus y squared minus x minus y minus x squared. So what I'm going to do is I'm going to look at the special product here. So since it's x minus y squared, well, if you remember back, our rule said that if we have x minus y squared, that's the first term squared minus 2 times the product of the x and the y plus the y squared. So I'm going to say I've got x squared minus 2xy plus y squared. If you wanted to FOIL that out, that would not be a problem with me. Show your work. Think that, okay, this is x minus 1 times x minus 1. FOIL it out. Combine the like terms. You get to the same place. Over here, okay, I got to make sure that I remember this negative, that negative is going to multiply this product. So I'm going to keep that product in parentheses. I need to take that negative. I'm going to have to distribute it to whatever terms I have after doing this product. So what I'm going to do is multiply it out just like I did here. So I'm going to have y squared minus 2xy plus x squared. If I can find it. Oh, there it is. It get moved. All right, so we've got that. Now, we got to deal with this negative. Okay, if we're gonna subtract by this polynomial, we need to take that and distribute the negative, change the sign on all 3 terms in that product. So my first term stays the same. My first 3 terms stay the same. I didn't do anything with those, but then I changed the signs on all 3 terms here. So I've got negative y squared, positive 2xy, negative x squared. And now I want to look at combining any like terms that I have left. So I've got x squareds. I've got an x squared and a negative x squared. X squared plus negative x squared, that's 0. I've got negative 2xy and positive 2xy. Well, opposites, they add to 0. I've got y squared minus y squared. That's 0 too. Everything that I have in there winds up canceling out. So this expression has a value of 0. And so when you're looking at that, hey, that happened. You know, everything canceled out. And so then the value of that expression is just 0. Okay? If you're going through these, you know, they may not all go to 0. Just be mindful. Think about, okay, what are my like terms? How do I combine them? Okay, when you combine like terms like this, add the coefficients, variables stay the same. So when I added negative 2 and 2, I got 0. Okay? So some basic review of multiplying polynomials.